Now, lecture 10, global properties of covariant derivative. You see, dx and y in another, also denote of nabla x and y. That's a covariant derivative. So consider x and y as a vector fields on a smooth manifold M. And D is identical. This is two denotation of covariant derivative. So this is a connection, covariant operator on the tangent bundle. Attention now, tangent bundle are related to global analysis on Tm. Now, these properties here will be derived, okay, in the lecture 11. Okay, when you talk about the local coordinates at point P. So the linearity in vector field being differentiated property here. So dx ay plus bz is a dxy plus b dy of dz. Number 2, linearity of a smooth function in the direction of vector field. So the property df, f and g are functions, okay? And this here operate on the z, the vector field z. Just this case expand as f dxz plus g dyz. And the third property, the Leibniz rule on the second argument. Property dx, f and y. Leibniz rule over here, f and y. So it's x, f, this is directional derivative, y plus f dx y, where, as I said, xf is equal to dfx, which we already showed this relation here. This is directional derivative of f along the flow x, capital X over there. Number 4, compatibility with the smooth functions. dfx y is f dx and y. And the relation number 5 is a relation to coordinate basis. Also global, okay? In coordinates xi, remember that xi are labeled, okay? So let the vector field x expressed in components. xi are the contravariant component, and partial xi are the bases, okay? Both belong to the vector space. Now y is yj, partial of xj. So dx of y, the covariant derivative in this case of y is xi. Now I plug over here just the covariant derivative of y, okay? Si, xk in this case, you see? So, as I said previously, our goal is to obtain the curvature, torsion, Riemann curvature, Ricci curvature, scalar curvature. So scalar Riemann, this case. So you be this, I start, okay, the objective, our goal, just the next lecture 11, which will derive the properties, the global properties applied to a local coordinates. You see, TPM. You see that this is P here. There is no P here because this is global and this will be a local. You see? So you see this in the next lecture. Okay? That's it.